Step into the cosmic realm where the secrets of the universe unfold before our eyes. Brace yourself for a mind-bending journey as we unveil the awe-inspiring wonders that the Hubble Space Telescope has gifted us. From unraveling the mind-boggling expansion of our universe to capturing breathtaking images of distant galaxies, this celestial time machine has shattered the boundaries of our knowledge, leaving us forever changed. Get ready to witness the universe in all its jaw-dropping glory as we take you on an unforgettable expedition beyond the realms of imagination. When considering Hubble's major scientific achievements, we should recognize that, because it studies an extremely wide range of astronomical phenomena, discoveries rarely belong exclusively to Hubble. More often, it was the combination of observations from several telescopes that led to the breakthrough findings. Hubble did play a crucial role, however, in all of the science highlighted here. Here are 8 things that wouldn't have been possible without the Hubble telescope. 1. The beginning of everything. In December 1995, Hubble spent 10 days peering into a tiny patch of the sky in the constellation Ursa Major. The result was the Hubble Deep Field, revealing nearly 3,000 galaxies in what was the longest look back to the beginning of the universe. Since then, astronomers have continued to push Hubble's view further and further back in time. The latest iteration is the Ultra Deep Field, taken over 200 hours in August and September 2012 with the Wide Field Camera 3, installed in 2009 during Hubble's last servicing mission. The image was made by a team at the California Institute of Technology in Pasadena, led by Richard Ellis. The 1995 version, made with the Wide Field and Planetary Camera 2, was a look back at the 13.8 billion-year-old universe when it was a youthful 1 billion years. Some of the galaxies in the Ultra Deep Field date back to just 350 million years after the Big Bang, or about 3% of the universe's age, explains Ellis. 2. What happens when a star dies? I was shocked, recalls Arsen Hajian when he first saw this image of planetary nebula IC 418 in 1999. The astronomer, who now manages a company that develops imaging and spectroscopy equipment, picked the object for his postdoctoral research on measuring the distance to nebulae because ground observations showed it to be round and featureless. We took an image expecting it to be simple and straightforward. What we discovered was anything but, he says. Hajian's reaction was a common one among astronomers who were seeing the early images sent to Earth by the Hubble Space Telescope, especially in 1999. The first time I could download Hubble data directly from the webpage, as opposed to waiting for a tape to show up in the mail. A planetary nebula forms when a mid-sized star, much like our Sun, starts to die. The balance between the inward pull of gravity and the outward pressure from nuclear fusion shifts as the star's hydrogen fuel runs out. When a star begins to collapse, the heat from this increased pressure ignites the helium, which explodes like crazy compared to hydrogen, Hajian explains. 3. Exoplanets in detail. In the hunt for exoplanets, Hubble isn't the first space telescope that comes to mind. NASA's Kepler spacecraft, launched in 2009, has found thousands of exoplanet candidates. The strength of Kepler is in the statistics. You learn a lot when you can detect thousands of planets, says Paul Callis of the University of California at Berkeley. The strength of Hubble is in being able to study a few systems in exquisite detail. Callis and his team began using Hubble to look for planets around the star Fomalhaut in 2004 and found an enormous dust belt. The detailed images, however, showed that the belt was an unusual shape, likely disturbed by the gravity of at least one planet. So in 2006, they went back to look again. Comparing the images, they found a tiny dot of light, 10 billion times fainter than the star. Fomalhaut B is the first exoplanet to have its picture taken. But even a picture isn't definitive proof for everyone. Callis extrapolated an orbit, but it didn't explain the debris ring shape, as the planet's gravity would push and pull on it. What's more, Callis says some scientists were concerned that the planet didn't appear brighter in the infrared, as a planet orbiting a youthful 440 million-year-old star should. 4. Spying on the neighbors. Years from now, Hubble will probably be most remembered for its breathtaking deep-field images, showing thousands of galaxies billions of light-years away. But Hubble has done plenty of impressive work in our neighborhood, too. In 1994, it took pictures as comet Shoemaker-Levy 9 approached Jupiter and was ripped to pieces by the massive planet's gravity, making enormous waves as it plunged into the gaseous atmosphere. It was a rare, spectacular event, and Hubble's observations gave astronomers new insights into Jupiter's composition. Though the planets in our solar system may not seem far compared to distant galaxies, ground telescopes looking through the atmosphere can still struggle to resolve small details. This photo of Uranus and its rings was part of a series that studied how the rings' appearance changed from 2003 to 2007 when they were edge-on toward Earth. With Hubble, SETI Institute astronomer Mark Showalter and his team discovered 2 additional outer rings, plus 2 tiny moons, Mab and Cupid. 5. How do you see a black hole? The idea of black holes was first considered more than 2 centuries ago. Albert Einstein's theory of general relativity started to define them in the early 1900s, and by the 1970s, astronomers were looking for signs of something that, by definition, they could not see. Instead of looking for the black hole, they looked for high-energy radiation given off by the matter being sucked into it. In 1990, soon after launch, Hubble began to search for the signature emission spectra of supermassive black holes in active galactic nuclei, where astronomers theorized black holes might exist. Using its infrared camera, Hubble was able to see through these dusty regions and measure the subtle movement of stars near where black holes were thought to be. A sharp rise in the velocity of stars close to the nuclei revealed a powerful. 6. The making of a solar system. Since the first confirmed planet orbiting another star was found in 1994, thousands of candidates have been identified. While astronomers continue to search for solar systems that look similar to ours, other scientists are focused on the debris that came beforehand. These protoplanetary disks, the dust and gas and rocks chaotically orbiting a young star, are the key to understanding how planets form. An early and still popular target for Hubble was the Orion Nebula, the closest massive star-forming region to Earth and an excellent target for protoplanetary disks. 7. Galactic fender benders. Among Hubble's significant contributions is its ability to confirm theories astronomers develop as they try to understand the universe. This image of the mice, NGC 4676, is one example of an observation that proved the model. Astronomers study galaxy collisions both to learn how galaxies form today and to look back in time to see how the very first galaxies may have been created in the early universe. We can't watch the collisions, as they take hundreds of millions of years to unfold, but looking out across the sky, we can find snapshots of galaxies in every stage of collision. Scientists use data about the behavior of colliding galaxies at each stage to create computer models. Then, educated guesses about the initial state of a particular pair of galaxies are entered into the program, and fingers are crossed in the hope the result looks like what they observe. 8. Light echoes. In 2002, astronomers noticed a star at the edge of the Milky Way that suddenly gave off such a brilliant burst of light that it was, for a time, one of the brightest stars in the galaxy. Hubble began to watch as the light bounced off nearby interstellar dust, like sound from a yodeler echoing off of mountains, says Howard Bond of the Space Telescope Science Institute in Baltimore. The star V838 Monocerotis is 20,000 light-years away. Astronomers were able to calculate its distance from Earth by measuring how its light moves through the dust. The 838 Mon is in a class of objects that change relatively quickly. For some, a pattern appears that can provide a way to determine distances in the universe. Type 1 supernovae, for example, are called standard candles because their explosions produce a predictable brightness. Astronomers have turned Hubble toward them to reliably measure distances. The detection of their movement through space confirmed that the universe's expansion is accelerating, providing evidence for the existence of dark energy. As we conclude this exhilarating journey through the discoveries made possible by the Hubble Space Telescope, we are left humbled by the immense impact it has had on our understanding of the cosmos. From its iconic images that have captured the hearts and minds of people around the world to its groundbreaking scientific breakthroughs, Hubble has rewritten the textbooks of astronomy. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.